Let's review a little bit and talk about what kind of graph each of these will give us. 9x plus 9y equals 144. Well, that's really easy. We know that if we just have an x and we just have a y, that's going to be a line. Now, here we have x squared. Only one is squared. That is going to be a parabola. We have x squared and a y squared. Now, they both have the same coefficient. So this is going to give me a circle. On the fourth one, different coefficients. So when I divide through with 144, I'm going to get different things in the denominator, which means I will have an ellipse. And let's talk about that ellipse. That's 9x squared plus 16y squared equals 144. And if I divide everything by 144, I will get x squared over 16 plus y squared over 9 equals 1. Definitely an ellipse. Let's talk about that ellipse real fast. Its x radius is going to be 16. So from the center, it's going to go out 4 and 4. I'm sorry, the x radius was 4. I said 16. Y radius is going to be 3 because 3 squared gives me 9. So I'm going to go up 3 and down 3. So I get this ellipse. We're talking about all those points on that line. Now, what do you think is going to change when this turns into a minus? Well, it's not going to be all the points that are the sum of the distances from those focal radii. We have a difference here. So let's talk about what that gives me. It's actually going to give me something called a hyperbola. A hyperbola is the set of all points such that the absolute value of the differences of those focal radii is constant. So we don't get an enclosed circle this time, or figure this time. So let's talk about what we do get. All right. Here's our y-axis. Here's our x-axis. We're still going to have our foci. Let's put one here, F1. We're going to put one here. And we still have our center and all of that good stuff. But this time, instead of being around those, we're circling outward from them. So we'll have one going one way and one going another way. Now you should remember something that looks similar to this, even though it was kind of angled differently, and it was a hyperbola that we'd looked at before. Now we can still use our equation to find everything that we need. We'll still have a horizontal distance out this way, A. We'll still be able to measure out a distance so far up, call that B. But instead of using those to have an ellipse inside, we're going to use those to make a little box. Now this box is useful because we can use it to make these slanted asymptotes. Now let's talk about everything we know. X minus h squared over a squared, but this time it's going to have a minus y minus k squared over b squared. So what do you think the h and the k give you? Well, that's the center as usual. The a gives us this horizontal distance, and the b is the vertical distance. So whatever's underneath the x gives me the horizontal, whatever's under the y gives me vertical. Now this is going to be a horizontal hyperbola, just like the one we have up above. It's going to open left and right. Now we have another option. We could have the y come first. Now if the y came first, how do you think that's going to change the hyperbola? Well, you're right. It'd be vertical hyperbola. It's going to open up and down. Let's see what else I forgot to tell you. Oh! How to find the foci this time. Now we still have a distance c, just like we did on the ellipses. But to find c, on the ellipses, we took the difference of a squared and b squared. On the hyperbola, we're going to add them together. So let's look at an example. It'll be a lot easier when you see it all put together. All right. We have the y first, so this one's going to open up and down. The other thing we can see easily is the center. We look inside the parentheses, x minus 4, so the center is going to have a 4, y plus 2, so it'll be negative 2. The next thing that's easy to see is that horizontal radius, or horizontal distance. We look under the x. What's squared gives me 9, that's going to be 3. Vertical distance, what squared gives me 25, that's going to be 5. And now we can go ahead and get a graph started. Now the first thing I need to do is get that center. So 1, 2, 3, 4, 1, 2. Here's my center. Now I need to get that horizontal distance 3 and the vertical distance 5. So I'm going to count over horizontally 1, 2, 3 and put a dot. 1, 2, 3 and put a dot. Up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now instead of using that to make my ellipse, I'm just going to kind of draw a little dotted box. Now this little box or rectangle is going to be used to help me find my asymptotes. Remember, an asymptote is not really there. It's used as a drawing guide. So if we need to make a note, this is an asymptote. And then we have one going this way. So they're the diagonals of that rectangle. Now, this one's opening up and down. So this point right here and this point right here are going to be my starting points. Now we're going to get really close to the asymptotes, but never touch. So that's how you would graph it. Now what if I was asked to find the foci? Well, since this is minus, for our foci on a hyperbola, we're going to add a squared and b squared. Well, that's 25 plus 9 is 34. So c is going to be the square root of 34. Now I'm going to add and subtract it to my center. So if we look here, it's not going to be over in here. It needs to be up here and down here. So for these points, the x value doesn't change at all. Still 4. The y value, I'm going to add square root of 34 to it, and I'm going to subtract the square root of 34. And that is how you graph and find the foci of a hyperbola. Now, what if it wasn't given to us that pretty? Just want to do one problem where it's not pretty. And we're going to practice completing the square so we can get it into pretty form. First thing we need to do is group our variables. Now, since the y is positive, I'm going to put it first. It's going to be 25y squared plus 100y. And then we have negative 4x squared plus 24x. I also want to move the constant, so when I bring it to the other side, it's going to be 36. Now, I'm going to factor out that coefficient of y squared. It's going to make my life a lot easier. So that's going to give me a 25, and then y squared plus 4y. And I'm going to leave a space, because in completing the square, we're always missing something right there. Now here, the coefficient of x squared is negative 4. So when I factor out a negative 4, I have to be super, super careful. Negative 4 times x squared gives me negative 4x squared. Negative 4 times a negative 6x gives me a positive 24 there. So be very careful when you're factoring out a negative. Now the 25 I'm going to leave right there. I know I want to make this something squared. And I want to make this something squared. Now all I have to do is find out what I want that to be. So if we look at the first one for y, I know this is going to be a y. This number is always half of the middle term, so it's going to be plus 2. What's missing is that number squared, so that's going to be a plus 4. You have to be very careful when I add it to the right side, because it's really not just a 4. If we look at the 25 is on the outside of the parentheses, so I'm really needing to add 25 times 4. Let me scoot over. Now, on the x's, this is going to be an x. Half of the middle term is going to be a negative 3. Negative 3 squared is going to give me a positive 9. Now, when I add that to the other side, it's not just a 9. It has a negative 4 on the outside of the parentheses. So I'm actually adding a negative 4 times 9. Now, when I simplify that right side, that's 36. 36 minus 36 is going to be gone. 25 times 4 is going to give me 100. Now, I am almost there. For ellipses and hyperbolas, we want that right side to be 1 for graphing form. So I'm going to divide by 100. And in the first part, I'm going to get y plus 2 squared over 4 minus x minus 3 squared over 25 equals 1. Now, what all do we know? That's going to be a center of 3, negative 2. That horizontal distance is going to be 5. Vertical distance is going to be 2. And since the y squared is in front, it's going to open up and down.